Hello and welcome back. I hope you had a relaxing 4-day weekend. I won't be here today or tomorrow, so first off, I want to start by giving you a rundown of this week's schedule. Today, your substitute will show this video where I'll review our methods for standard form graphing and factoring trinomials. You'll get a worksheet for practice, and you'll turn this into the sub tomorrow. Tomorrow, I'll have another video where we review the vertex form for graphing, and we learn something new, a difference of perfect squares factoring method. This is a pretty basic factoring method, which is really just based on patterns, so I think most people will be okay. You'll get a practice assignment tomorrow, and you'll turn that in to me on Thursday. On Thursday, I'll go over solving by factoring, which is something also new to us, and we'll have time to practice and review in case you had any lingering questions from today or tomorrow. Friday, we'll be taking our first quiz for Chapter 5. It will cover sections 5.1, which is graphing, and 5.2, which is factoring. Let's go ahead and start with a review for standard form graphing. If you want to add this to your notebook, you may. Otherwise, you could just follow along with me on the screen. Let's go ahead and start with f of x equals 4x squared minus 8x plus 7. This is in standard form, which, if I look at my notes, is y equals ax squared plus bx plus c. I'd like to write my form right above my problem because it makes it really easy for me to see what a, b, and c are equal to. Next thing in my notes, it will tell me to find my vertex. And it says the first thing I need to do is x equals the opposite of b over 2a. If you don't have this in your notes yet, remember you can get the notes on my website. We'll go ahead and put in the opposite of b, which is positive 8, divide by 2 times a, which is 2 times 4. So I get 8 divided by 8, which is equal to 1. So the first part of my vertex, or my x-coordinate for my vertex, is 1. If I know the x-coordinate, then all I have to do is plug in to get y. And that's what my note will tell me is my second step. So everywhere I see x in the original equation, I'm going to go ahead and plug in a 1. Then I evaluate through the process of PEMDAS, or the order of operations. First step is to do that exponent. I'm squaring the 1, which gives me just a positive 1. 4 times 1 is 4, minus 8 times 1 is 8, and then plus 7. Negative 4 plus 7 leaves me with 3. So the y-coordinate on my vertex is 3. If I have this xy ordered pair for my vertex, I can go ahead and graph it on my coordinate plane by going right 1 and up 3. And if my vertex is 1, 3, then my axis of symmetry is just that x-coordinate of my vertex. So axis of symmetry is at x equals 1. I can go ahead and draw a vertical line on my graph representing the axis of symmetry. The next step in graphing is to just get some other points on the coordinate plane, and they should help form that nice U-shaped parabola. I had given a hint about what kinds of values to put into the table of values, and my hint is go back to the axis of symmetry. So if the axis of symmetry is x equals 1, choose two numbers that are really close to 1. I'll choose 0 and negative 1. You could choose 2 and 3. Now I'm going to take these x values and plug them back into that original equation. F of x equals 4 times 0 squared minus 8 times 0 plus 7. The nice thing about using 0 is it's pretty easy to evaluate in standard form. 4 times 0 squared is just 0. 8 times 0 is just 0. So when I plug 0 in, I get 7 out for y. I'll repeat the same process for negative 1. 4 times negative 1 squared minus 8 times negative 1 plus 7. Follow my PEMDAS like I did for my y of my vertex. Negative 1 squared is a positive 1. 4 times positive 1 is 4. Negative 8 times negative 1 gives me plus 8, and then I have plus 7, which gives me a value of 19. Now, that's a little bit larger than my coordinate plane actually has room for, and that's okay. That just means for this particular problem, I'll probably only graph one other point, 0, 7. So I'll go 0 left or right, up 7, plot that point. I'll reflect that point over the axis of symmetry that goes through my vertex. And I can kind of tell I have a really skinny parabola. So I'm going to go ahead and draw a U shape as best I can. So I've just completed a graph for the standard form of a quadratic function. Next, we're going to go ahead and review our factoring trinomials. If you were here on Thursday, we started talking about this, and I said I would teach you the magic number method. You don't have to use the magic number, but I recommend it if you don't already know how to factor. Those of you that were gone on Thursday last week, follow along with us, write down some examples, and maybe during work time, find a buddy who can help run through the process with you if you're having difficulties. So section 5.2 is factoring, and we're going to be factoring trinomials today. First, we'll list some steps for successful factoring if we're in the form ax squared plus bx plus c. This is a trinomial because it has three different terms, ax squared, bx, and c. It's also the standard form for a quadratic function. The first step to successful factoring is factor out a greatest common factor first, if possible. Not all trinomials will have a greatest common factor, but if they do, you should take it out first. The second step is to draw your parentheses. Remember that factoring trinomials is really unfoiling or undistributing. So you want to draw those parentheses that are like what you would have had before you multiplied. Okay, here's where we start our magic number. We're going to start by multiplying a times c. That will give us what we call our magic number. We then want to find factors of a times c that can add to make our b. If a times c is positive, then our factors have to be the same sign, positive, positive, or negative, negative. If we multiply a times c and get a negative number, then our factors for a and c have to be different signs, positive and a negative. Make sure that you have the right signs for your factors. If you don't have the right signs, then your final answer won't be right. And last, you'll plug these numbers into your parentheses, and don't forget about dividing at the very end. We'll look at 4 examples, and then you'll have some time to practice. Let's start with 7x squared plus 29x plus 4. If I look back at my tips for successful factoring, I should check if there are any common factors for the numbers 7, 29, or 4. But there aren't. So I'm going to go ahead and start with my magic number process. I'm first going to draw my 2 sets of parentheses. And then I'm going to find out what my magic number is by multiplying a times c, which is 7 times 4, or 28. And now I'm looking for what are factors of 28 that can add to make my middle term 29. Well, those factors would be 28 and 1. 28 times 1 will give me positive 28, And 28 plus 1 will give me positive 29. So I drop those two, plus 28 and plus 1, into my parentheses. The next step is what to do for the first term in the parentheses. Remember, we're going to go up to this very first term in the trinomial, 7x squared. We're going to put in the 7, we're going to put in the x, but we're going to leave off the square. And we're going to do the same thing in the other parentheses. So we put 7x in the first and 7x in the second. We know this isn't right because now we have too many factors of 7. 7x times 7x gives me 49x squared, not 7x squared. But we'll look at our two sets of parentheses, and one or both of them will divide. In this case, it's my first set of parentheses, 7x plus 28. Both of those numbers are divisible by 7. So don't forget that step where you go back and divide one or both of your parentheses. My final factor form is x plus 4 times 7x plus 1. This is my final answer for factoring. If you want to check to make sure that your factoring is right, you could just redistribute. Do x times 7x to get 7x squared. X times 1 to get plus 1x. 4 times 7x for plus 28x. And 4 times 1 for plus 4. Combining like terms, I get 7x squared plus 29x plus 4, which is the original problem I worked. You don't have to do that check step. It's just good if you're ever wondering if you picked the right numbers or if you picked the right signs. Let's try another example. This time let's do 4x squared plus 38x plus 70. Going back to my tips for successful factoring, I'm first going to check if there's a greatest common factor I can take out of all these numbers first. 4, 38, and 70 are all even numbers, so they're all divisible by 2, which means I can factor out a 2. The 2 doesn't disappear, it just hangs outside a bigger group of parentheses. And I run through each term and divide it by 2. So 4x squared divided by 2 is 2x squared. 38x divided by 2 is 19x. And 70 divided by 2 is 35. This 2 will just stay outside all my parentheses for the rest of my problem. It's there, but I don't really have to worry about it. So I'm going to be doing magic number with the trinomial inside of the parentheses. So I draw my two groups of parentheses. Remember that extra 2 is just hanging out in front. And then I work my magic number. 2 times positive 35 is positive 70. I'm looking for factors of 70 that can add to make 19. Now, if you have a larger number like 70, feel free to get out a calculator and divide 70 by some different numbers to find the factors that work. In this case, the factors that work are 5 and 14. So 5 times 14 gives me 70, and 5 plus 14 gives me 19. Those are the numbers I'm going to drop into my groups of parentheses. So I do plus 5 and plus 14. And remember, for the first term, I go to the first term in my trinomial, and I copy the 2, I copy the x, but I leave off the x squared. So I put in my 2x. And one or both of my factors should divide. So I'm going to go ahead and divide this 2x plus 14 by 2, since they're both even numbers. Remember, this 2 at the front just hangs out. I'll have one factor that's 2x plus 5, and the other factor, x plus 7. And this is the factored form for the trinomial. Another example, x squared minus 2x plus 1. We still work our magic number for this one. Two groups of parentheses. I should check if there's a greatest common factor. These numbers are pretty small, 1 and 2, and there isn't one. So I'll go ahead and start my magic number. When there's not a number in front of x squared that you see, there must be a 1. So 1 times 1 is positive 1. And I'm looking for factors of positive 1 that can add to make negative 2. Well, factors of positive 1 that can add to make negative 2 are going to be negative 1 times negative 1. They have the same sign, so when they multiply, they'll be positive. When they add, they'll give me a sum that is negative. So I drop in the minus 1s. And remember, we go back to the first term, 1x squared. We drop in the 1x and the 1x. Leave off the square. And what's really nice about this, anytime that leading coefficient in front of your x squared is 1, there's really nothing left to divide. Both factors are divisible by 1, but then they'll just be themselves. So my final answer is x minus 1 times x minus 1. I'll do one more example. This time x squared plus x minus 12. Check for a greatest common factor. These three terms don't share anything in common. So I'm going to go ahead and set up my two groups of parentheses. Multiply my a times c to get my magic number of negative 12. And now I'm looking for factors of negative 12 that can add to make a positive 1. Remember, if my product for a times c is negative, then my two factors are going to be different signs. I run through my factors of 12, 1 and 12, 2 and 6, 3 and 4, and 3 and 4 are the numbers that I want. Because if 1 is positive and 1 is negative, they'll make negative 12. And if I make the larger number positive and the smaller number negative, when I add them, I'll get a positive 1. So I drop those numbers into my groups of parentheses, a minus 3 and a plus 4. Remember, go to that very first term, that is 1x squared, and leave the square off, dropping in only the x. So my final answer is x minus 3, x plus 4. It'll take some time to get used to this factoring method if you haven't used magic number before. Next, you're going to be given a worksheet to practice. It has mostly factoring on the front and then some graphing of standard form on the back. Please use the time in class wisely to work. An answer key will be available at the front of the room, and this video is posted online if you need to view it. Go ahead and try your homework assignment.